So this is kind of a little bit different than all the other flip-flops we've been looking at, and that's because it's all broken out. It doesn't have any submodules here. This is the asynchronous D flip-flop. And the first thing we should notice when we start up the simulation is that we have Q and Q naught are both equal to 1. But there's actually a pretty clear reason why that's happening. It's because we're sending some conflicting information here. This is our preset signal, and this is our clear signal, but we see we've got this underscore L on there, underscore L. And what that means is that they're low activated. So that means when this signal is low or is 0, it's going to try and preset. And when this one is low, it's going to try and clear. And so this is trying to set it, since they're both 0, this is trying to set it to a 1, and this is trying to set it to a 0. So it's got conflicting information, so we shouldn't be surprised that our device is breaking. But these are our asynchronous inputs. And so when we don't want to do anything with them, since they're active low, I'm actually just going to set them both to 1s, right? Set them to 1s, and so that means they're just kind of in their passive state. They're not controlling anything, and this should work as a normal D flip-flop. So as I clock here, right, I'm clocking and my output's not changing because I'm writing a 0. If I want to write a 1 and I give it a positive edge, there we go. Q is now a 1. And now I can clock and I wrote a 0. But let's say, regardless of where the clock is at, I say, all right, I need it to be a 1 because I'm writing a new number into this memory device from maybe it's like a manual override. So what would happen is this preset signal would have to go low because it's active low, and it would force Q to a 1. And then that would go back up, and it's going to stay like that, right? Because this is an edge trigger device, not a level trigger device. And so say maybe now some stuff happens and D decides to write back to a 0, and then maybe it writes to a 1. And then, just like the preset signal, our clear signal works the same way, whereas if I want Q to become a 0, I just need the clear signal to pull as a 0, or needs to go low, and it forces Q, regardless of the clock state, it forces Q to be 0. So actually you can see I can clock and do anything I want with my D inputs, and it doesn't change because that asynchronous signal is staying as a 0. And so once the signal actually goes back to a 1, then this will work as a normal D flip-flop.